So greetings everybody, and welcome to example 8 in our series on cross products. So what we're asked to do in this problem is to identify the vectors that are unit vectors which are orthogonal to vectors u and v. Well, if we want a vector that's orthogonal to both of them, then that will be the cross product, because that's one of our kind of important facts, is that u cross v is orthogonal to both u and to v. So kind of computing the cross product, we can see what kind of vectors that we have from that. So just using our kind of matrix notation to remember how to compute that. So we've got our vectors I, j, and k. Then for u, we've got 1, 0, 1. And for v, we have 9, negative 2, and 12. And so what this will give us is our first component, our first determinant is going to be get rid of the first row, get rid of the first column, 0, 1, negative 2, and 12. Our second one, we change the sign, and we have the determinant 1, 1, 9, and 12. So we get rid of the first row, get rid of the second column, and then for the third one, get rid of the first row, get rid of the third column, gives us 1, 0, 9, and negative 2 for our vectors. And so what do we have then, kind of as our cross product? So we have 0 minus a negative 2, so we have 2. We have 12 minus 9, so that's going to give us a 3, but then we change the sign. And then finally we have a negative 2 minus 0, which just gives us a negative 2. Okay. So this gives us our cross product of u and v. If we then kind of check to see what the unit vector is going to be for that vector, what we find is that the length of our cross product is just going to be the square root of 4, 2 squared, plus negative 3 squared, which gives us 9, plus a negative 2 squared, which gives us a 4. And so we have the square root of 17. And therefore, one of the unit vectors that we have that will be orthogonal to both will be the vectors, the first vector, so our cross product being unit normalized. So we have 2 over root 17, negative 3 over root 17, and a negative 2 over root 17. And so we see that this gives us the first vector. And then for the other vector, the second vector, orthogonal to both u and v, will be the negative of our normalized cross product. And so for that, the negative of the normalized cross product. And so what we then have, what that will be, is just the negative of that vector. And so we have a negative 2 over root 17, a 3 over root 17, and a 2 over root 17. And so for that, what we then have is the second vector. And so those two vectors are the unit vectors that are going to be orthogonal to both u and v. So I hope you've enjoyed this problem, and I will see you guys in the next one. Take care.